Okay, we've already talked a little bit about what method you can use for question 3. Again, I suggest that you do this as a conditional proof. Remember, there were 2 suggestions I had. One would be an indented conditional proof. So, in other words, you do 2 conditional proofs, one within the other. That would be, you would say, assume P here, and then maybe do what you can do with P involving line 2, and then shortly thereafter you assume M. So notice you have a double indent here. This is a single indent, this is a double indent. And then having assumed M, you're going to try and get L. Let's say you get L down here on line 15 or something. And then you go back 1. So you go back to the level of your first assumption of P. So you go, as I said, suppose this is Narnia, you go back out to Wonderland. And what have you proved? You've proved if M, then L, by conditional proof, all the double indented ones, 6 through 15. And then what you notice is on the single indent, the first line is P. So you go back out to the real world. The first line is P. The last line is M, then L. So you have to put parentheses around it because you want to make sure that this stays the main connective. And you've done conditional proof 4 through 16. That would be one way to get the conclusion. Alternatively, as I said last time, you could notice that if P then M then L is actually equivalent to P and M then L. It's equivalent by exportation. So you work that out sort of by yourself off to the side, and then let's see, you assume the antecedent of that, because that's now going to be the conditional that you prove. So on line 4 you would assume P and M. Now the advantage of that is you don't have to double indent. So you just have to finally go down to, say, about line 20 and get L. Then you go back to the real world, P and M, then L by conditional proof 4 through 20, and then you do exportation, P then M then L by exportation 21, and you got the conclusion. Now what about the rest of the proof that I've kind of omitted in the middle? Well, one thing to notice is when you have P, you can get if N then Q. When you have M, you can get if Q then O. You can do something to get rid of the Q's, and then you will be able to use if N then O here. And that's all that I'll say about that. I'll let you work the rest out. It's not that hard. Now with this one, it's not going to be a conditional proof. You're just going to have to do a regular old kind of proof. And as I suggested, notice that you can simplify both sides of this, you can simplify both sides of this, and you can use S with this one, and you can use T with this one. And that is going to give you something that's going to help you with this. I will give you a hint and say De Morgan's law is involved at some point. Another thing to notice is that you have S, and if you have S, you can make S or W by one of the inference forms, and then you can do modus ponens with this one. And eventually you're going to try and get X out of there, and you're not going to need to assume anything. And I think that's enough clues.